Hello everybody, let's go ahead and dive into 2.5. We're going to have some application of linear equations today, which I find very exciting because, why else would we learn math if we couldn't apply it? And today we're going to be able to predict the future and the unknown. So let's dive in. So scatter plots are just like, you see a whole bunch right here, 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 and here. Those are scatter plots. It's a graph that represents two sets of data by plotting the data as ordered pairs. So data. It's like you're like given hey, here's some stuff we found, and it's data, and you plot it. The correlation between that stuff is the strength of the relationship. Like, how well do they actually correlate together? Does one kind of predict the other? And if you've got a strong correlation, then you can be like, yeah, that's a pretty solid prediction. Or if they're like, yeah, that doesn't really match up, then that's a really weak correlation. And you can see this one's negative because it goes downhill. This one does go downhill, but it's not quite as strong, like tight knit together. So that's a weak. This one, there's no correlation. There's no up or down trend. This one's a weak positive because you can see like it definitely is going up, but it's not like a super strong. And see how these are so much closer together? That's why that one would be considered a strong positive because it's going up. I have a fuzz on my screen. Okay, here we go. So the correlation coefficient indicates the strength of the correlation. Now, the TI-84s do give you the correlation strength. It's an R value. It's always between 1 or -1. If it's 1, it's a perfect positive relationship. And if it's -1, it's a perfect negative relationship. I'd like to give you an example of a positive relationship. Like for an infant, how many months old they are and how much they weigh. That's a pretty positive, strong correlation because the older they get within their first year of life, the more they weigh. Maybe how about let's do a weak correlation. A weak correlation would be something like the more time you spend watching useless television in your grade in math class, something like that. So like the more time you spend doing things like watching TV or not applying yourself, the downwards your grade will go in most cases. All right, so the line of best fit by definition is the trend line, and it gives the most accurate model, which is linear regression. So it's the actual line that you draw that goes through all your points as best as possible. Let's take a look at example 1. This graph shows the number of hours and the amount. Let's change that word to say amount. Sorry about that. That should say amount. Okay. This graph shows the number of hours and the amount of money you earned each day last week. How many hours should you work to earn 200? What assumptions did you make to find your answer? Explain. So what I want you guys to see about these dots is they're definitely trending up. I don't have a ruler, but like if I drew an up line like this, that really isn't a very good up line because it doesn't really balance stuff. If I drew an up line like this, again, it's not really a really great balance. But if I wanted to like hit as many points as I could and be like the most accurate in between all my points, I would probably draw something like that. To me, that looks pretty good. It's a good balance of all of those dots. And what do they want us to ask about? $200. So if you read my graph right, 200, it looks like it would be like 9-ish hours. And the reason I found that is because 200 would be, 200 would be here. Oh, wow. 200 would be here. So if I kind of look at my line, 200's happening somewhere around here-ish. And that's about 9 hours. So I would say 9 to 10 hours to make my $200. And so you're drawing a line that fits the points and then using that line to estimate the future. So let's take a look at example 2. Example 2 is using scatter plots. Now this website right here, I don't know if we can grab that or not, but I know I posted it on Schoology. This website right here That website does linear regression for you, because these calculators over here, these they're limited to what we can do, because like we didn't pay for them. Okay, so I did post the calculator online that will do it for free. So let's talk about utilities. This table lists the average monthly temperature and the electricity for a Texas home in 2009. The table displays the values rounded to the nearest whole number. Make a scatter plot. How would you describe the correlation? Now, I'm going to go ahead and plot these points. This might take a little bit of time. Maybe you guys want to pause the video and plot them yourself, and then you can kind of fast forward through me plotting them. I will talk through it, but again, you can just take the time and do this yourself and fast forward. So I'm going to do 61 and 150. 61 and 150. So that would be 160. This would be 150. Right there. Let's see. 58 and 139. So 58 and 139. There-ish. 67, 172. 67. See, this would be 200. This would be 160. So 170, again, just pause the video if you need to. I did this one. I'm on 67 and 172. 67. 172, so that would be 170. 67 would be like here. 75 and 205. So here would be 70, 75 and 200-ish. Up. 79 and 170. So almost 80 and up to 170. Okay, 83 and 234, so almost 80 and almost 230. Let's see, this would be 240. So essentially 80 and 230. Whoops. 80 and 230-ish. Okay, 84 and 255. 84, 255 would be like here, and 84 would be there. Again, we're doing the best we can. 85, 245 is going to be literally in the same area. 81 and 210. Be here. 76 and 183. So here's 77. Here's 75 in between 70 and 80. And 183 here. 65 and 132. So 65 is here. 132 would, let's see, this is 120. So 132 is going to be between those. Not the easy, I mean, feel free to zoom in, okay? And then 58 and 110. 58 is essentially 60, and then 110 is like here. Okay, so we have our points, and now let's take a look at what they want. Make a scatter plot. How would you describe it? I would like, these are pretty close together in my opinion, so I would say it would be a strong and it would be positive, okay, because it's going uphill left to right. So all of that to say it's strong and positive. In other words, as the temperature goes up, the electricity also goes up. I know that definitely happens at my house because we use electric to cool our house. So yeah, and it definitely is true, because the warmer it gets in the summer, the more expensive my electric bill is. If I'm not mistaken, that is the end of the first page. So I will stop and get a new video for my second page.